Before I jump into this entire topic, right, I want to ask. Ever since I think this moment dates back to 2022, 23 when people got really gung-hoed by what AI can do to their enterprise applications, right? So, at least in my experience, I've seen a lot of companies trust the internal teams to use AI very often and explore the cases where the interfaces can be made much better, right? What interfaces traditionally existed as dashboards or clickable interfaces, websites, they're all now, they're trying to make it conversational, right? I think my question to most of you on this forum is, I'm sure at some point in time you have either tried some of these solutions where you try to do text to SQL because most of you are from data and analytics background, or you have tried to build it yourself. I mean, there are some method in which it's been approached to solving this problem, right? So the first question is, how many of you are trying to build this in house? Very interesting. And what has your experience been? Like, is it doing well? Are people really liking it?
Uh, the use case is dramatically it's required.
Okay.
Team is always asking,
Okay.
but making it very accurate
Hmm.
and very contextual towards
Okay.
schemas and all that.
Yeah.
There we are feeling a lot of challenge.
Okay.
We are having one or two type tables. I think it's work fine.
Hmm.
It's able to infer
Hmm.
what I'm
Hmm.
asking for.
Hmm.
But when we have multiple schemas and
Correct.
queries is getting nested,
Complicated.
yes, that's where it fails.
Okay. Okay. And any other experiences? Have you guys tried anything like this from any other, let's say, vendors? There is a ton of them out there, right? Like if you actually open and just type text to SQL, you'll find 20 such.
Some others also were building,
Yeah.
maybe we could get like some more experience.
Yeah. So what are the experience of building this, trying this, doing this internally? What has your experience been?
Yeah, so actually, like I work in another Excel-backed startup, which actually enables text to SQL.
Hmm.
So I myself have tried a lot of things.
Hmm.
So like yesterday itself, like I was trying Snowflake's intelligence platform.
Correct.
It's quite new, right? So what I feel is for the Genie and for the Snowflake's Cortex,
Hmm.
what they're doing is they are showing in the demos that there is a perspective analysis that can happen.
Hmm.
But they are mostly just doing simple text to SQL.
Hmm.
And that also kind of not works when your semantic view or let's say your Unity catalog has a lot of schemas and tables with documentation.
Hmm.
So when the scope becomes huge, it starts hallucinating.
Hmm.
And I have specifically seen that joins is a big issue that SQL it's not able to write properly.
Hmm.
And apart from that, one small thing which I feel is that currently so the thing is that metadata has become a huge issue. So even if you put all the metadata in the semantic view of Snowflake or let's say in the Unity catalog, the agents are not properly using that. So all of these factors are creating a huge mess when it comes to enabling the text to SQL for enterprise.
It's very interesting. I want to ask this question. How many of your companies uh, actually maintain really good metadata of your big data catalog? How many analysts or how many data engineers actually write human readable descriptions? Or all tribal knowledge? Like usually this lives in the brains of an analyst, right? So is there any company I want to know, like, because I never maintained it for 7 years of running data. So is there any company which maintains really good metadata? So yeah, I mean that's the fallacy of metadata, right? It's very hard to keep it up to date, and it's hard to get people to write metadata really well. Well, interestingly, some of these levers you spoke about is exactly what we have tried to tackle in our approach to this, right? So the question we started, which is, I would like take a step back and even think of the motivation behind this problem, right? I think what you said makes a lot of sense, which is uh, what generally I think many internal teams try to achieve is the kind of unlock which a developer would achieve if they use a developer, as AI assisted developer platforms, right? Like the Cursor, the Windsurf, the Cloud Code. So there is a gap today where why would Cursor work really well for developers and they fall in love with it? Cloud Code people just love, the productivity is 10x. Why is that not replicated to an analyst or a data scientist, right? So why is this a hard problem to do this on a data level, right? So uh, there is a gap here, right? So the first gap is, I would say, there is truly AI native capabilities, which is your generative AI and agents and all of them. And then the second complexity is the enterprise complexity of data, right? So there is today, I would say, the gap that needs to be bridged is not a small gap, unlike code, right? Because think of it like most data is a multi-hop reasoning problem. It's not a single hop reasoning problem. If you actually take a cursor, give it your Python code, give it your Java code, the entire context the AI needs lives inside the Git repo, right? So virtually what happens is there is no multi-hop reasoning that is needed, or there is no switching of context even for the AI agent, because everything lives inside. It is so hard for data to be that way, right? Because the problem is your data exists in S3, your catalog exists in some AWS environment, your metadata exists somewhere else, and some companies don't have metadata, right? So your schema lives in many places. It doesn't live in the Git repo, right? So this becomes an incredibly hard problem mostly. So I think while people talk about text to SQL, these are actually the fundamental rate limiting levers today to even get this accuracy right, right? Because it's a much broader and much more modular ecosystem than code, right? Codes are mostly monoliths when you come to just how do you develop and the entire developer workflows go. So we have tried to kind of attack these areas that should kind of enable a true co-pilot or a cursor kind of experience, right? But I would like to ask one more question here, right? Like, how many of you, I'm assuming, how many of you are analysts, by the way, show of hand? How many of you work in analyst and data science, and how many of you are in data engineering space? So largely data engineering, right? So let's say in your teams, data engineering teams, you will be building data marts and you will be optimizing your Spark jobs and etc., right? How has the experience of working with Cursor been? Have you guys tried data AI-assisted coding platforms for data engineering workflows? So is it a hit and a miss, or
We haven't tried.
we haven't? Oh, okay. Yeah, go ahead.
Yeah, so I think what we have seen so far is pretty encouraging.
Hmm.
We've used plot
Hmm.
primarily for code conversion,
Hmm.
and it seems to be pretty encouraging at this
Hmm.
point in time. But the bigger question is when it gets deployed in a production environment, right? So what is that we'll run into is something we are yet to face.
Hmm.
So
No, but how has your developers' experience been in using
pretty
Cloud
good.
Code? Okay.
Pretty good.
And any what are the insights there? What do they find it really good at, especially from the data engineering standpoint of view?
Yeah. So primarily, uh, we've been focusing on converting code, let's say, from a source a SQL construct to a target SQL construct.
Okay.
So that we sort of have built tools which were based on Antler,
Hmm.
grammar, and sort of invocations using Java code, right?
Okay.
And the Antler grammar file, creating the Antler grammar file using Claude has been a pretty big hit.
Hmm.
And the efficiencies have increased significantly. We were able to convert SQLs from Oracle and DB2
Hmm.
to the target platform in a matter of week.
And it's deterministic and accurate.
It has been pretty much deterministic and accurate so far.
Amazing. Amazing. And that's unlocked your team's productivity, and you don't. Okay. So a lot of operational overhead just gets wiped out.
Yes.
Very interesting, right? So I think the power is pretty. I mean, most of us in the forum will agree here that it has massive unlock in terms of let's say the power you give it to your data engineers or the data analysts, or even the experience that it can actually uncover for your business users. I think that's why the strive has been, and at least for a couple of years, there has been many attempts to kind of nail this text to SQL. There's a lot of open source products that are trying this. There are a lot of enterprise products trying to get this. But what we have truly approached it is from all the problems that we have actually discussed. The idea here is how do we try and kind of uh, build it to a scale which can cover the enterprise complexity, where the schema is messy, the schema is really big, the knowledge of your enterprise lies in the minds of an analyst, right? There is siloing of data. So all of these are real world problems which are the barriers to actually build a good I think AI agent on text to SQL, right? So our approach has been fairly straightforward, that you go and solve these complexities and truly make it a co-pilot, right? So we don't believe that it's going to be a SQL monkey writing one SQL and giving you nice answers on a toy data set. It should work on real world schema, a true co-pilot to a data engineer or a data analyst, because he can work with the AI agent, right? That's where the power is massive. And then what would otherwise take you a lot of time, right? Think of writing a data mart, think of writing uh, bespoke queries for ad hoc analytics, which will usually take you 30 minutes, 45 minutes, or 1 hour, should be done in minutes, right? And that's where the true power lies, where the enterprises can actually harness. And we have gone one step ahead. So what we also feel is text to SQL is a very limiting way of thinking of the problem, right? We are not here to say, hey, give me an NL question, I'll give you an answer. The actual problem here is going from data to insight, right? Which means it's usually a multi-conversational problem, because if you think of a business user, if you think of yourself writing a data mart, if you think of yourself optimizing some SQLs, you don't stop at one text to SQL, right? So what you essentially do is you kind of have a follow-up, continue to optimize, continue to make it better, continue to ask different questions, different slicing and dicing. So what we have also done is we have gone one step ahead and we have made it a truly conversational platform. So which means you're not just getting text to SQL, you can have a complete conversation with the platform so that you arrive at the goal. So this is rather than text to SQL centric, it's a goal centric platform where you start with a goal in your mind, that hey, I want to today get up in the morning and I work on uh, in a e-commerce company, and this is the data mart I want to optimize. That's your problem statement. Your problem statement is not I have an NL question, convert to SQL, right? So we have also tried to attack the journey to getting to that insight in the product as well. And we started with high scale from the beginning, because we knew that there is no point giving 10 tables or 15 tables because the enterprise schemas are complex. So we started with a very high scale, and our internal benchmarks show high promise on really high scale. Hundreds of tables, thousands of tables, and the best part is there is no migration of your data, right? We are not a database company, so the data lies where it is, and without any migration, our platform can actually just plug and play into your current data set. So you may be on a Snowflake or a Databricks or a Trino, BigQuery, whatever it could be, we work with you, right? There is no need to actually go and say, hey, you know what, there is a migration complexity. Our text to SQL, our AI agents will sit right on your data and help you get your job done. Right? I think we covered this. Is there anybody who wants to kind of weigh in on what are the challenges in, if I may ask you, like what prompted you to actually go to text to SQL? Is it because analysts are choked, or is it because the business users always are curious about data? So what prompted you to kind of thrust into this?
It was a use case to just enable business folks to
Hmm.
query our data
Hmm.
directly.
Hmm.
So that was the simple use
Hmm.
case. And with that, we were able to do with the semantic kernel and writing small codes and try it out. It's worked. But when we are having production grade schema,
Hmm.
and then we are opening that tool to the
Hmm.
business folks,
Hmm.
and they usually ask here and there
Hmm.
lot of
Of course, yeah.
right? So we have feel that 50% times it's not accurate,
Hmm.
and it's failing also.
Hmm.
Even
Fair
though
enough.
we have given a lot of context
Hmm.
of schemas and all that.
Okay, okay. Any other challenges, specifically people who have tried text to SQL in their companies, or as a user or as a builder? Go ahead.
Yeah, the main challenge which comes to like why we want to go from text to SQL is because the data is very complex. We sometimes want to go for the aggregate queries.
Hmm.
And if, like in my company use case, we wanted to convert to the natural language search. So we had a lot of tabs for searching, just like LinkedIn.
Hmm.
LinkedIn has location, company, for job search.
Okay.
They recently converted to one natural language search.
Hmm.
So I think if we want to go for the aggregation query,
Hmm.
which is complex,
Hmm.
so then we'll be needing good text to SQL.
Okay, but from what I can hear, it's mostly unlocking people who are curious about data. And is it because some of the analyst teams are bottlenecked, or is there a consistent back and forth between, let's say, the availability of an analyst versus uh, the rate at which the queries come in from the business users? Is that a fundamental rate limiting factor across many companies?
I don't think so right now.
Hmm.
That's the problem.
Hmm.
It's a matter of giving that features to the
Okay.
business page.
Okay.
Because we are having technology in the market the way industry is promising.
Hmm.
Seeing all those factors, industry is deciding to move in that direction.
Interesting. Okay.
I have to add one more point.
Yeah, sure.
See, we have multiple stakeholders like product teams, right?
Yeah.
They're coming up with different use cases for our data.
Hmm.
If we have 150 plus reports, still like we need analysts to build new dimension of the same report.
Yeah.
So if we're giving next 7 days, 3 days, and 3 days metrics, 20 days are like previous years, this month's metrics like that. So we can't go and build each report.
Of course. Yeah.
So that's the problem.
That's an interesting. Yeah. I think that's a very interesting use, because we'll talk about that, by the way. Yeah. So what we started out with, and some of our research indicates there are 4 really big barriers today, right? And one of them will kind of allude to what you're saying. First one is enterprise complexity, and enterprise runs into typically 2 to 3 major complexities. First one is, of course, you have a messy schema. I think that's a given thing. Nobody really does catalog cleaning. So you have thousands of tables, and your tables have complex relationships. Somebody just spoke about joins, right? It's an incredibly hard problem, because think of everything which an analyst is doing. He has enough tribal knowledge so that you don't have to prompt and tell him like, hey, you know what? How do you standardize this? He knows this automatically, right? It's years and years of knowledge which they have accumulated being in the company, and that's not easy to translate, right? So, and the second one is working around your ways of governance and security and complexity, right? I think these are typically really big problems that companies actually run into. And the second one is speed versus analysis. Imagine an analyst, getting a query from the business users all the time. The reason why they get this all the time is because I don't think canned reports are enough to make decisions anymore, right? Because think of any dashboard. The curiosity is infinite, right? You are always trying to make business decisions. The stress on data is high. Things are getting more real time. Things are getting more data driven. Canned reports are not going to cut it. One-day reports are not going to cut it. The industry is competitive. How can you quench infinite curiosity, right? So either you have to go to an analyst, and the analyst is busy answering hundreds of other queries. So you can't have infinite analyst pool as well. So there's always this gap. And I think as industries get more competitive, this gap is going to be even more pronounced, because everything is going to be data driven, and everything's going to be decision oriented completely on your own data, right? So this gap is only going to get more pronounced as the companies grow and the industries become more competitive. And one major problem also here is repetitive SQL, right? Like think of an analyst, think of a business user who has absolutely no basic SQL capabilities, right? So they just don't understand how to write SQL. Drains an analyst to write simple SQL all the time, right? So some of them are just doing repetitive, mundane work just to get an answer. So there's also a motivation problem here that kind of leads to the gap in the speed versus the required answer, right? The third one is again data access divide. This happens both in real time, where some of the users have access to real time data. It also happens in schemas, where some analysts or some teams have access to some schemas. Some people don't have access to other schemas, and they have no clue what's happening across schemas, right? And when an analysis comes there's a data access divide. And the last one is, I think this is now a very widely discussed problem, which is the AI demo to production gap, right? I am sure you must have seen hundreds of blogs and at least tens of products which claim to have text-to-SQL, right? I think we are no exception to it. Many people are trying to crack the problem. But it takes a lot of effort to go from, hey, I can make it work on 5 tables, to saying I'm truly production ready, right? So that requires multi-hop challenges to be solved. So I think we see these are the four primary gaps. So the way we approach the problem is very simple. I'll kind of spend 10 minutes on how we kind of deep down solve this problem. We see this, how to solve this problem predominantly as a two-step problem, right? Step one is, how do you make sure your AI understands your data well, right? So if your AI understands your data well, most AI agents and most LLM-based agents are so powerful that they can write any SQL in the world. So think of having an analyst who is amazing at writing SQL, but he just doesn't understand your data, right? He doesn't understand your schema, right? He doesn't understand what is there in the brain of an analyst. That's exactly the problem we try to solve first. The first problem is, how do you make sure that you give me a schema and we convert that to rich metadata and descriptions which agents can understand? That's just step one for us. So what we have done here is we have actually created a metadata plus semantic model, right? So as you can see, the first problem here is you as a user, your company as a user, we will try to understand what your schema and table metadata is. So think of a schema that has 50 tables, 100 tables, your typical goal data, right? Once we get access to that, we kind of profile the data, try to understand like what's there in the schema, and we also use the query history. This is where the knowledge of joins come in. So usually it's very, very difficult to kind of nail accurate SQL with just understanding names of the schema, right? Because enterprise data is far more complex. So what we do is we augment the schema metadata which we understand with your query history, because where is the wealth of all the knowledge of structural relationships that's in your query history already, right? So it's also a fundamental barrier in code first AI native platforms to SQL first AI native platforms, because SQL and databases have the problem of relational structures, right? Because your code is not just linearly connected, it has defined structure, and that needs to be understood. And one source for us is to understand your query history, right? So because all the analysts have already written queries, and we leverage that to understand how your data structurally connects to answer specific kind of questions, right? So using these two, this is basically agentic in itself, right? So there's an agent which converts and understands what's the semantic model of your schema. What are you actually trying to represent in this data, right? That part will be understood by the agent. And from there, the second step is fairly simple, which is you build an AI agent which can go and answer your questions, right? So I would rather call this as a pre-training setup or building your views. So this is basically helping AI understand your data. That's like step one for us. And before I jump into how we actually build the AI agents to answer your questions, is there any question on this? We'd like to take your opinions as well. Yeah, please go ahead.
As per your diagram, there is some interaction with semantic data with text-to-SQL
AI agents, yes.
So, what are the use case which you?
So what happens here is in semantic model of your schema is this schema is now ready for your AI agents to answer questions, right? After doing all of this, that green box just indicates that we are now ready to answer your questions. The purple part and above is actually the agentic flow where a user fires a query. So he writes a prompt, which is an NL question. What happens is the agent refers to the semantic model of your schema to resolve the answers. Yeah.
What about candidate search?
I'll come to that. So that's the next step of how.
So yeah, one question.
Yeah.
Regarding the agentic text to SQL,
Yeah.
that might be using the LLM.
Yeah, we are LLM agents, yes.
So have you like tried with some tabular models or models which understand this columnar or tabular relationships?
No.
Or if there is some difference in your performance?
So that's what I think I spoke about this. We think most of the LLM agents like a GPT or a Claude or a Bedrock, Grok, etc. I think they're more than capable of writing good SQL, right? I think that part is, in fact, they're now so strong that they even understand some of the most commonly used dialects like a Spark or a Snowflake, right? So I don't think the actual LLM agent is the problem here. I don't think we need specific models. What we need is general intelligence about your schema. I think we have approached it as a fundamental schema understanding barrier problem, because I think once at the first box, which is candidate search, once your agents can understand, hey, this is where my information lies to write a query, they do an awesome job at it. We don't even have to do much there. But all the efforts are into making, how do you make the search happen, right? Because imagine thousands of columns and like 10,000s of columns rather in like hundreds of tables. How do you nail down that 20, 30 column that fits into your context window, right? Once you do that, I think the rest of them is a fairly trivial job.
So, is it offline or online? So, do you connect to the source database platform and
So yes, we do connect to the source database platform. It's online.
okay, and building the, so you're saying that in the absence of, let's say, a relationship diagram,
Yes.
something like Levin,
Yeah.
which used to be there back in the
Yeah.
day. So you're going to build that relationship
Yes.
based on the metadata.
Based on the query history. So it's an evolving problem, right? So what happens is if the relationships are not explicitly defined, the relationships are already implicitly defined because people are writing queries on the data, right? So which means tables and columns are being connected structurally. It's just that we are not able to leverage it. So what we do is, where is this data lying? The data lies in user's query history, the system query history, right? So if you're using the Databricks platform or the Snowflake platform, they give you all the queries that are executed in the past 10 days, right? So we use that, and then we have an architectural, we actually are not just semantic model driven. By the way, many companies which are trying to attack this are semantic model driven, which is largely on LLMs and search space. We augment that with knowledge graphs. So what we do is we convert your query history into a knowledge graph, which can structurally identify these are the columns and tables relevant when you actually write a particular query. So using the query history, we convert the query history into the relationships, which we can understand.
Maybe a follow-up. So this knowledge graph, is
Yeah.
it also generated via a model, or is that?
So we have our own proprietary logic for that. So what we do is we have an algorithm that converts that to the knowledge graph. So typically, if you look at this, right, I'll tell you what the problem is. This, I think, is again alluding to the joins problem, which is, imagine when people write a query that touches 2, 3, 4 joins, right? It's very hard for an LLM to get it in one shot, right? So what we do is we prompt and hint, saying, hey, you know what, this query, but when we actually walk it through the knowledge graph, these tables are connected, right? So somehow this could be relevant as well. So usually joins get very, very stronger once we have a graph approach. Yeah.
You mentioned about general intelligence of users schema. That's
Yes.
the main thing, and then building up the knowledge graph of that.
Yes.
How do you measure and quantify your accuracy of the entire model?
So this is a hard problem. The way to do this accuracy is in two methods. One is you create gold data sets on open source data sets. I think that's pretty much what many companies try to do. And we do support all of this TPC-DS, TPCH, New York City taxi and all of that, right? That's one way to do. The second way to do is there are open source evaluation data sets like Spider 2.0, BERT SQL. I think we score well there as well. But I think that is a very rate limited thing, because think of a Spider 2.0, right? It came 1.5 years ago, where most of the text to SQL was actually on the encoder first architectures, which is mostly on RAG and your fine tuning LLMs based architecture. We don't follow that architecture anymore. So I think the rate at which the agent space is evolving, most of the benchmarks are outdated in 6 months anyway. So the true way to test this, I think, is you should have a set of gold SQL and you just run it through the gold SQL. And you say, hey, you know what, I have gold NL pairs and SQL pairs, let's say 50 of them, and then just go ahead and test it. So we follow a mix of both, and we do score very high on the open benchmarks as well, but we don't limit to that. Like, we don't think that's a relevant way to benchmark at all. So I'll give you a very simple example, right? Like, so we were trying to do benchmarking on one of the open source data sets, and we were getting an accuracy of around 60%. then we were like, what is happening? Because it's performing really well in our data set. So then we realized the limitations of open benchmarks, right? So what they expect is you need to return exactly the same SQL, which means you may get your join conditions right, filter conditions right, everything, but you need to also return the exact select columns, which is unfair because uh, while you may get exact answers, you may also go above and beyond because our system is conversational. Because some of the standard benchmarks also expect you to return IDs. Like if the answer is just a bunch of IDs which are humans can't understand, what's the whole point of text to SQL, right? Because you want to have a conversation with it. So the moment we actually expanded it a bit, we saw much better results. So I think there are some limitations in open source benchmarks, so we don't buy them. But the true way, if we were to like work with your companies, we will just work with you on like 50 questions and see what the accuracy is. Yeah.
This semantic model, right?
Yes.
Is it built on the rule based or any ML?
This is not rule based. This is LLM agent driven. So we have agents that can understand and make schema documents. In fact, one side benefit of this is you actually always have metadata for your company because we generate the metadata anyway for our agents. But this is purely LLM driven, agent driven metadata model.
Okay. So many of the LLMs that you use just
So we are very heavy on Anthropic and OpenAI. So it works well for both of us, but I think it should work well for most of the LLMs in the market. I mean, you can use a Gemini, you can use a Grok. It should pretty much be the same.
Quick question: do you see, your companies wanting to use the model that was selected by the central team, or is there freedom to choose any model? Like, if you were to think of a production use case.
so the model, right? So the data science team
Hmm.
will sit on the top.
Hmm.
So they will approve the model.
Hmm.
So we have to choose among them.
Choose their model.
The brand also. So if it is not there, if it is not listed, it is not approved by data science team.
Hmm.
That's what we
Then we ask them. So this is the model which is outperforming. So we need it. Then they will evaluate. They will do testing at that level. So they will input that. So that is another area. So we are heavily on the Databricks. So we have AI queries for the same kind of products. We will give the within the cell. We will give the prompt. What I meant join. So Databricks inbuilt feature, that is AI function.
Yes.
AI function. So we are leveraging those. So it is pretty good. So even data analysts also they are using it. So but the complex it increase as and when you go to production.
Yes. Yes. I think that leads me to this. So what is it that we are doing that kind of solves these structural problems, right? So we think text to SQL is not a fairly simple problem to solve in terms of, just get an LLM, give it the schema and it'll answer the question. I don't think it works that way. I think many companies which are not doing well, or the ideas that took off like a year ago but not working in production, typically run into these issues. So our architecture is based on three fundamental levers: agents, tools, and memory, right? So each agent, because we think SQL involves multi-hop reasoning. If you think of how an analyst would write SQL, it's not a linear flow, right? He will go write a SQL, figure out there is something missing, goes up, improves the join condition, comes back, changes the filter condition, comes back, right? So SQL is always a multi-hop problem, not a single linear workflow, right? So we have a bunch of tools and not just one, a bunch of agents and not just one agent. And each agent has specific capabilities, right? So, and we'll come to that in a bit. The second one is tool augmentation. So how many have you have actually seen in your daily use cases, let alone text to SQL, see agents actually hallucinate? Right? Or you say it made assumptions which we are not comfortable with, right? And that's true for text to SQL as well. At some point in time, we have seen that it assumes columns, it assumes tables, it hallucinates, right? It makes up schema which doesn't exist. So the way to solve this is we have tool augmented reasoning. So what we do is hallucination is a feature now, it's not a bug, because hallucination is what makes them creative. But you need to actually give them tools to ensure they don't hallucinate or assume, right? So which means points where a LLM agent is actually assuming, making up schema, instead of doing that, just prompt it to use tools better. So we have made tools so that LLM agents don't have to assume or hallucinate column names and table names. Third one is memory. this is a very understated aspect. Now think of it, right? Like somebody did all the hard work working with a text-to-SQL system, and they nailed an NL query pattern and a SQL, right? Which means it was a fairly complex 7-8 join problem with the right filter conditions. The second person should not go through the same problem, right? Because more often than not, the concentration of queries is imminent in a few gold data sets, right? So what memory fundamentally enables us is to ensure that yes, we make mistakes, but we make mistakes once. We don't make mistake multiple times. So which means I wrote a NL query, I struggled with it, I made the SQL accurate. The other person writing it for the same pattern will not face the same problem because it always retrieves from memory, right? A fourth one is smart retrieval. So usually what happens is NL is a typical infinite problem, right? Anybody can ask any question. So I can open a text to SQL and say like, who's the Prime Minister of India, right? Like, so I can't control the input. How do you ground it? How do you ground it in tables is the crux of the search problem. So the first green agent you're looking at, while the lead agent is the one which is orchestrating the entire flow, trying to make sure that all the agents work synchronously, the first agent does exactly this. Tries to figure out using many search combinations, how do we retrieve the right amount of candidates. Again, we have 200,000 context, right? 200,000 tokens is the only context we have. So we can't just throw all the queries, all the tables at it. So how do you smartly prune and give X amount of columns and tables so that LLM can actually write an answer to this, right? So one agent does specifically that. The second agent, I think this is again something which we have done, which has worked well for us, is we have approached writing, converting NL to SQL as a SQL engine problem, right? So SQL engines get this right all the time, right? Once you write a SQL, how do they actually typically approach it? No matter how complex the SQL is, they make a plan. They go and figure out the filter conditions. They go figure out the join conditions. And we have just agentified that flow as well. I think that's the benefit of us being a SQL engine company in the first place. What we have done is we actually create a natural language plan. So SQL again is a complex problem, right? So we have our own natural language, I would call it NLAST, syntax tree, but I would say a logical plan where we make the AI agent break down SQL into, hey, these are like, I know the NL query is really big, but these are like the 7-8 steps that I need to do. And I think that is also giving us a lot of grounding into accuracy. And we also have SQL generation, and the last one is reflection, which is very important because what we have done is once a SQL gets generated, we also have an agent which reflects on the NL question, the tables and the columns and the candidates that it retrieved, and finally the SQL. So there is a reinforcement loop which is built in. So sometimes it does make mistakes, and when it makes mistakes, it actually comes back and retries again because it knows it has actually made a mistake. So we have put in a lot of effort to ensure that as no assumptions, no hallucinations, tool augmented reasoning, and then ensure that you get a much accurate SQL using all of these tools. Our agent again goes beyond this. So what we do is we don't stop at just SQL generation. We actually give you visualizations as well. I'll show it to you during the product demo. It gives you smart visualization so that you can actually understand and get an insight out of it. You can also do a web search. So think of an analyst workflow, right? If it's a true co-pilot, most of us are dependent on some kind of a chat GPT search or a web search to kind of complete our tasks, right? So there's no context switching needed. You can actually ask, just like how you ask any LLM, any normal question, you can actually ask any general questions to our agent. You can also do a web search. You can actually break out and let's assume that there is an analyst in Swiggy who is particularly working on a query, and then the query comes in, hey, what's the same metric for Zomato, which could be there in their public filings. Just do a quick web search and get the context back, and your agent holds that context. So that context is relevant for your further conversations, right? One more agent which we have worked on, which kind of grounds it in enterprise, is what I call the rules engine. So think of any enterprise today, they already have their gold views, right? Which means you know what your CLTV is, or you know what your key metrics are. You have a SQL template for daily active users, right? So in that case, my agents should not be thinking what the SQL is. At some point, the agent should just follow saying, hey, you know what? I don't need to think about the SQL already exists. That's also a complex problem because to make an LLM not think too much and make sure it grounds into the rules, right? So you have a rules, enterprises always have rules to play with, right? You have your own definitions, SQL templates built in, and your agents have to follow that exact SQL template for that metric. Those are also now agentified. And the last one is dialect agent. So we have currently started with our own engine. So no LLM today truly understands all the dialects well. That includes the Spark and Databricks dialect or Snowflake. It always makes mistakes. So there is an agent in our agentic system that exactly understands what it is to write a SQL query on E6 data, and then it makes sure that it executes the data, executes the SQL perfectly on E6 data by actually making the SQL which is E6 data compatible. So this is predominantly the architecture which we follow. So yeah, so go ahead.
Are you persisting the values to the memory?
Persisting what?
Any values to the memory?
Yeah, so memory for us comprises of three things. The first one is the question you asked and the answer that we gave. That is anyway part of the follow-ups. But we also do store artifacts. So what tables did we retrieve? What columns did we retrieve? What was the SQL? All of that. So we keep it as part of the memory. Yeah, go ahead. Yeah,
That reflection is like
yes.
it, depend on the user's feedback or it is
Nothing. It does it automatically. Yeah.
So it is going to fix the
Yeah.
errors.
Yes.
Good.
So I think that is one of the key levers of accuracy, because it goes through the flow, but sometimes it makes mistakes. But reflection agent, interestingly, doesn't understand any of this. So reflection agent doesn't understand what the main agent has done. It just says, boss, I got this natural language query. This is my schema context. Does this make sense? Right? So it uses all the schema metadata we generated from here. It says, okay, this makes sense or doesn't make sense, or what are the mistakes?
Any score is giving for each.
No, we don't do that way. We typically go and fix it. So we don't score it, but something is off. This is on the TPC DS dataset, which is a very well-known public dataset, right? And we asked a fairly complex question that requires it to join, I think, seven joins, right? It has to make 7 joins, 7 accurate joins, pick the right filter conditions, pick the right columns. The TPC DS schema is also fairly messy because there are multiple date handling complexities. And the question was on New York with a high household income, right? So this is a query that we generated. If you can see this here, we got the right filter condition. So a lot of our agents actually have tools to ensure that it doesn't assume filter conditions, right? It goes and actually profiles your columns and get those filter conditions. Found the right column where the filter condition exists. And also, when a question is as abstract as high household income, what is high, right? Like you don't know what is high. So our agent actually also profiles the data and figures out what is equal to high, right? So, which means why is that 50K? Why is it not like 150K, right? Like it actually goes, profiles, figures out the median value, and then comes back and says this is high household income. On the contrary, look at this. This is another computation which is fairly used. It's well-known this one. Hallucinated this column. The New York value doesn't exist in CACT, right? It doesn't exist. So made a mistake of New York, made a mistake of picking the wrong column. And when somebody asked high, it actually picked up the highest column, right? The user is not intending to do that. So query deconstruction is a hard problem. How to understand an NL query and how to interpret it is a hard problem, which the multi-agentic system. Sorry? I'll tell you when I meet you for coffee. So let me just quickly switch to the demo, all right? Yeah. So this is our engine. It is a simple conversational interface. We will fire a live query, but I'll just go through some of the things which we discussed. I'll start with, let's say, a query as simple as this. What is the monthly web sales for the year 2002? This is typically on the TPC DS dataset. We get you an opportunity to bring your own dataset here, right? Any datasets that you want to actually query on, you can keep switching the datasets. And what we do is we create semantic views on the fly, right? It takes a couple of minutes, but it just generates the views on the fly. But here's an interesting part, right? So what you want a co-pilot to do or a true companion to do is to understand or to explain what it did. And because we are a planning first natural language to SQL agentic product, we actually first tell you the plan. Right? So even something as simple as this was a 4 to 5 step plan, right? It has to go join web sales with this column. This is the step 2, this is step 3, step 4 and step 5. So an analyst working on this will also understand, did it actually go and approach it correctly, right? So after that, it actually returns the results to you and suggests intelligent follow-ups, because again, as I said, you are not actually stopping at what do you want to know here, right? You want to actually now go and have a conversation with you want to get to your goal, which is what is it you wanted to achieve when you started out. Suggests intelligent follow-ups because it understands your schema, it understands the question you asked, it has memory. So the follow-ups are far more sharper in terms of what you're trying to achieve from the intent standpoint of view, and you also have charts that actually plot without you having to work around, right? So think of even getting this done is a 10-minute problem for an analyst, right? To get the SQL right, to get the join condition right, to get the filter right, does it in a couple of minutes, right? And you can keep going, right? So now it has the benefit of the memory is it understands the context. Can you execute a simple select star query on a table with limit length? Yes, it understands, right? So now you can keep going on a slightly more complex query, right? Think of this. This is almost 300 tokens, which is, I think, it's a lot of heavy lifting for most of the text to SQL systems, right? So it has to interpret, get the filter conditions right, and it also ensure that it executes a SQL, converts to the correct dialect, gets all the SQL constructs right, and also go through the plan. So this is a 9-step plan, right? So which is a lot for a text to SQL. Imagine an analyst writing almost 5 to 6 CTEs to get this done, right? Does it in a few minutes, and then once it does it, it generates the data, shows the top X amount of rows, and gives you what it means. There's also a summary. It doesn't stop there. It also goes and tells you what the data means, right? It says with an average price of approximately this, all items had inventory categories between. All of that suggests follow-up questions, gives you insights, gives you charts on how they work, and then now you have to follow up, right? You want to now actually truly understand. You want to ask a follow-up question on your data. You said, how does the inventory quantity correlate with current price of these? It understands what you're meaning here. It understands you're actually referring to the previous query, executes the answer, gives you the charts, right? So your journey is not just text to SQL, your journey is data to insight, right? And we also have this place where you can go and create your own rules, your own metrics, and ensure that the AI never thinks about your SQL template, rather just adheres to that SQL template. I think most enterprises, in your case, it could be a Tableau or a Power BI, or where your view or a DBT, where you define these metrics and views. We have connectors to them, and what you can do is you can basically go and define this here. So in this case, let's say average order value is something I don't want my AI to think, right? I want it to just go ahead and just do this. This is the actual SQL template. So now when you actually go and write a SQL query, average order value, it understands, okay, I don't have to actually think about average order value. So it actually goes and picks up the same template. The average job, web sales net paid as the average order value. So, this could be extended into your governance. For example, let's say you want to write a simple rule that says, hey, you know what, no matter what happens, if a customer, or if a user using this says, give me all the credit card numbers, give me all the IDs, give me all the email IDs, give me all the phone numbers. You can actually write governance rules here. So no, even if you have not defined these in your catalog, this can automatically understand what it's returning is a phone number, and it should not show. It will automatically write a redact function. So enforcing how the data is also shown to users, right? And we also can borrow the existing governance which you have defined in Databricks and Snowflake and any of those products you're currently on. So let's say if somebody tries to ask a question in the schema that he doesn't have access to, that can be actually stopped here as well, right? So I'd like to take a pause here. Any questions? I would rather fire a query and then, but I would love to take questions while the agents get to work.
I have one question.
Yeah.
So there are other enterprise catalog tools like Databricks or Unity catalog, right? So do you also support borrowing metadata from those enterprise catalogs?
Yes, we do. So the way we do this is the engine that powers this is the E6 data engine, and E6 data engine supports all these catalogs without moving your data. So
Will you refine
So what you see on the right side there, that's what our AI agents generated, right? So what is the meaning of this table? Our AI agents first anyway generated a semantic view, so it understood this data. So this data is accessible to you. So if you want us to update the catalog, like, that should be a fairly straightforward problem.
So it always works with structured data, right? If there is unstructured or semi-structured data.
Yes, so that's a limitation today, but we will overcome that. So we don't support semi-structured data today, the JSONs, map, struct, etc. But that's not a hard problem. So I would not say that's a rate limiting factor, but that is the product that exists today. But I would rather think of it as a 2 to 3 month problem, because eventually JSON data and struct data are also parsable and indexable. So anything indexable is convertible to NL and queryable today. So
Metadata generation you doing by your own, right?
yes,
There won't be any other intervention of SMB side or
there is no intervention, absolutely. So what we do is, so I'll tell you like what we do. So we profile your data, right? So we say, hey, this is our like 5 values of what it looks like, what's the data type, what's the table name, and using a combination of them, we actually use our agents to, we have prompted our agents to understand this data. Like what's the cardinality of your columns? Like, is it an integer? Like, what could it possibly mean? We augment that with some agentic knowledge, and we generate the schema descriptions. I mean, again, this is our own proprietary agent, which automatically converts your schema into understandable natural language questions.
Are you suiting the data out, the big data in Parquet format?
No. So while your Parquet data exists as is, all this metadata is converted to embeddings and stored for your NL agents. But this itself is just simple text, right? So we keep it in memory as of now, but we can write to Parquet as well. As I said, like, we are generating that anyway for our agents to understand. So it's not very hard for us to expose it to all of your users.
What kind of tools help you to avoid hallucinations?
Good question. So we currently have worked on a couple of tools. The first tool is the planning itself, right? So and adherence to planning is the first tool. So which means what we do is we don't let the agent think about what the answer should be. We rather ask the agent with the tool assistance to break it down into steps. So that's the first thing, because once it breaks down, it does a fairly reasonable job with a complex query, right? The second tool, which is really helping us, is the data awareness. So whenever it writes filter conditions, whenever it picks up join conditions, right, it needs to be actually aware of the actual values. For example, if I write a join between A and B, does this make sense? Right? How do you know it makes sense? Because it has to now understand the column data. So once it understands the column data, it never hallucinates. And that's typically the example which I showed here. That's exactly what is helping us here. So how do you know CA state is New York? Because there is a column called CA city as well. And by the way, this is even more complex because New York is represented as a state and a city. So there's New York City and there's New York, right? So now it has to go figure out. So what happens is, when it may retrieve, it may search and get both city and state are viable columns for me to answer the query, it can't now decide. It should now go and actually profile and say, hey, where does New York actually exist, right? So tool augmented reasoning, especially on values, is something that is giving us a lot of unlock. So in fact, if you can look at this here, I think this is typically the miss. Because it may find similar columns, but if it doesn't have tools to understand which one should it pick, it goes and assumes it, right? So as I said, like, assumption and hallucinations are features. It is, you need to work around them. There are no more bugs. So
is it, for example, for this data set, you would be running the experiment and ensuring that it is not hallucinating. But if it is unknown fresh data, how much accurate you can say that?
yeah. So you saw this here, right? This flow is basically the crux of understanding, right? Which means, let's say your data updates every day, right? I would rather say data update is fine, But the time your schema evolves, let's say for example, you added a new table, you added a new column, or you introduced, then just run the pre-training flow. This typically takes around 30 minutes for around, I would say 500 columns and 30 tables, right? So once you do that, it's up to date, you can query. So the problem here is not data update. Data update happens every day, right? That you can't control. The problem here is the schema evolution. So that is one way. The second way to do this is if you can automate it. This is one of the features we have in the roadmap, that we are going to be actually building an automation to this, right? It's almost like your DAG running. Well, every day it can wake up, incrementally understand, has the schema evolved. If it's not evolved, it doesn't do anything. If it's evolved, it can just go and train itself. So
for that case, do you store a mapping of the text and the query?
Yeah.
And with some hash key or something like that, and then maybe sort of look at whether you need to regenerate the query or not, right?
No. I'm talking about the pre-training setup. So let's say you chose a schema. The schema has 10 tables today, right? And I don't need to retrain my semantic model again unless you introduce a new table or a new column, or you evolved a column. Let's say the column data type changed, etc. Data appending or updating is not a problem for me, because actually semantically nothing changed for me, just the data changed. What we are saying is we don't store anything, but the moment we sense that yesterday I had 10 columns, let's say 100 columns and 10 tables, today I have 111 columns, which means something in your schema changed, then you can go and trigger the setup.
What I'm asking is, because every time if you have to do this afresh, meaning convert the text into SQL, you'll be using up the tokens, right, and all that will come into picture.
No, but I am doing this only when schema evolves. No, I am not doing this when I am actually writing the query. What I do here is I convert these into my embeddings. It's one shot. After that, it's always referring to the embeddings. Nothing has changed. So I have all this text you see here. All this text you see here that is needed to answer the query, I convert them to embeddings. So that pretty much doesn't change for me.
No, but the point is, let's say if I change New York to, let's say, Chicago.
That will not affect, because that's a change in your data. But actually this didn't change, no? If you ask the question to Chicago, Chicago also exists in the same state column or the city column.
But the embedding
for
that would be different.
No, it's not different. Why should it be different? Because
Values won't be embedded.
values are not part of embedding.
You profile the values to find the correct city and replace. The information or broad detail on what possible values are present will be embedded, but the exact values are extremely dynamic in nature. You cannot possibly
Correct.
store all of the cities, all of the states in a proper column and index those. So that happens at some
Runtime.
Runtime lookup is what.
So that's runtime. So what happens is, if you see, and also what our agent does intelligently is it goes and, let's say, profiles this opportunistically. It has to answer a question on state. It went and profiled, and it got New York, Chicago, everything, all the 52 states. It caches it intelligently. So next time when somebody asks a question on Chicago, it actually just goes, hits the cache, and it says Chicago exists, so I'll get it. So the values are never part of the embeddings. Values are opportunistically done by the agent. It actually writes a mini SQL there. It's a select distinct from this and give me the answer. So what would actually confuse is the state and the city here. So the column description of state and city are embedded. That may be confusing, but we don't go and take each value into your embedding space. That we can't afford to, right? There'll be like millions of values. What about the performance of?
So, value that is generated.
Yes.
Right. So let's say if it runs, it's a badly written query.
Yeah, I'll come to that. Yeah, I'll come to that. I think I have an example. Let me just see. So by the way, this is one thing I forgot to cover. Let me just go to example somewhere. Yeah. So by the way, if your table is partitioned, so basically if you look at an analyst, there are two ways. See, think of this as an analyst. It's not like a extremely so today this is I would not say a very profound data engineer who understands the nuts and bolts of an optimized SQL, but it can still do a fairly good job in terms of writing the overall SQL structure for optimization. The first one is partition awareness. So if a table is partitioned, it always uses the partition key, right? So that is there as part of our rule agent. I think we covered this here. So the gray agent here, rules and part. So that always ensures that if your table is partitioned, the partition keys are used. So that's one way to prove. The second way is it always, because of the plan, ensures that it writes a CTE. So which means all the filter conditions and all the processing you do will all the, I would say, predicate pushdowns basically, right? Like you filter out data before you do processing. That is implemented into this already. So it already optimizes through CTEs and pushing your data and filters early and through partitioning. So more often than not, this would be a fairly performant SQL. But we can, so one of the benefits we have is, I mean, I don't know, you guys should tell me, like when an analyst writes, I think these are the two biggest levers. But if there's any other lever which you think is...
One other thing is that by virtue of actually using the E6 engine behind the scenes to execute the query, where the engine itself already does some optimizations in terms of generating proper plans, rearranging, join ordering, all those things, we get some benefits from there, right? So bunch of these things, all like what he said in terms of the agent actually takes into account the actual partitioning scheme of the table and the engine doing some more optimizations on top of the plan generated put together. I think it's fairly performant based on what we've seen so far.
I mean, let's say the database engine itself supports, I'm saying OLAP functions or window functions.
Yes.
Right? And that's what we run into. So where we see that, the DBAs, they look at the queries which are running and then they say that, hey, probably an OLAP function would have been better. Right? It is performant than, writing it the other way. So those aspects.
Yes.
So we periodically update our agent with the underlying capabilities of the engine as well. As and when our engine evolves to support more complex transformations or operators, as you say, that is periodically updated as well. So the SQL it generates most of the times is in attune with the actual capability of the underlying engine.
Yeah. So if you look at this agent, dialect agent, that dialect agent today completely understands E6 data. Which means the way to optimally write, even our prompts are tuned that way, right? When you generate a SQL, it should be optimal. It understands E6 data and it always ensures that it uses the higher order functions to ensure that that part is a given, I think, that it will do. It goes beyond that also. For example, even with all of this, two critical mistakes which most people do in writing is, one is they don't actually use filter conditions very early in the query. So they end up writing filter conditions much late. So they do a lot of processing. Imagine like, as the tree gets very complex, even SQL engines can't optimize if you miss a partition key or if you actually do filter push downs later. That it does automatically. So engine specific things are a given. Like that it will do, it uses the higher order functions, the best functions. But even after that, what an analyst would typically miss is something the rule agent will cover. Or even the reflection agent, that case will also cover. So it will look at the SQL. It also has the capability to say, hey, this is not an optimized SQL. So it also has the prompt to go and optimize the structure of the SQL as well.
So is it comply with only E6?
Today, yes. So what powers this is E6 data. But I mean, the way this works is it's a complete serverless kind of a model where if you were to bring this to your enterprise, it will just give you the answers without having you to worry about what query engine it's running on. So I think that's the experience we want to build. We want to truly build a conversational experience. We don't want you to go to the mechanics of where it is running, etc. So it's coupled with the engine. And that's what is also driving the delight of this. For example, partition aware, all of that is because E6 engine also has been tuned to ensure that it gets the partition keys, etc. So it's deeply coupled with E6 engine today. In fact, the entire performance levers are coming from the engine integrated. I think we're reaching the hour. Maybe a minute if you have any questions or.
And there is also QR
Oh, yeah.
if anybody wants to try out.
So, as we are dealing with NFP to SQL, right?
Yes.
There would be scenario of domain-related data sets, and it's very contextual. Our natural query is very contextual to that particular domain. For example, medicine,
Yeah.
retail, and all that.
Yeah.
So, how do you bring that kind of contextual?
Yeah, so didn't get chance to go through the roadmap. Two exciting things that will probably come next quarter. One is bring your own model. So you can actually choose if you have an enterprise account on Claude and Bedrock and all of that, you can bring those models to our agent. The second one is we are going to be working a lot more on enterprise grounding. So for example, either you give us a website link, right, where we can go through your website, or if you have, I would say, a set of custom instructions for the agent to understand anything that can enrich the prompt. We are going to be bringing up in the rule agent that you saw. We are going to be bringing up custom instructions. So in the instructions, you can go and describe, hey, this is what this table means, which means I already generated some context. You can either edit it or you can add custom instructions. Say, this is how you interpret this. And that will automatically flow into our prompts as well. Well, it does a fairly decent job without that today, because it is very, very aware of what it needs to generate a SQL. But we will bring that up in the next quarter. Just a quick, I think I'll just take a minute. I think what's exciting, what things we have planned ahead is a true copilot mode. So we are planning to bring in a SQL editor that can truly work like a copilot, right? Which means you can start in your AI pane like cursor. You can write a query, a natural language query. It executes the SQL on the left side in a query editor. The results are contextually passed to the AI, so it understands and interprets the results, and it can go on and on, right? So that's in the works. And we are also planning to bring in cross-conversational memory, which means it is now aware of conversations of your entire enterprise. So it doesn't make mistakes. It is something which truly understands across enterprise what tables are used, what columns are, what constructs are used, and it will be, every user will be able to leverage that benefit. And going ahead, I think, SQL again is a fairly complex problem. Today, it is limited to executing one SQL at a time. But maybe in Q4 of this one, we'll be bringing up some capabilities of deep research where it can execute multiple SQLs. Sometimes you may have some ML constructs, right? Let's say I want to run a correlation analysis, some Spark which could be needed. All of that could be, all of that will be part of the entire conversational experience. And sorry guys, way out of time. I'll be right here, so if you guys want to catch up, feel free to just talk to me. And then you can always scan this QR code if you're really interested to try the product out. We'll be very happy if you guys can try it out and give us the feedback. Please go ahead and sign up for this. All right. Thank you, folks. Thank you so much.
10-15 minute break and then we
Sure. So there's a 10-15 minute break. We'll reconvene for the second session after that.